Hello everyone and welcome back. So today I'm going to start a new lecture series on Laplace transformation. So it's a very important concept because in almost in all engineering courses, then in your graduation and post-graduation courses, you'll find the application of Laplace transformation. So that is why it is very important tool. Now, before going to start, so if you haven't subscribed the channel, so kindly subscribe so that you get and also hit the notification bell so that you get the notification of all the upcoming lectures on Laplace transformation. So before going to the Laplace transformation, let us try to understand what is transform concept. What is transformation? So if we take a function, suppose f of t, then under some transformation, it can be not only Laplace, there are so many other transformation also. So under the transformation, when this particular function goes under this transformation, so there are some changes, then it will change to suppose what? S. So here S is a parameter which is independent of what? Independent of t. So see, there is no connection between t and s. So after transformation, so it comes to a completely new variable. So it's already transformed. Okay. Now, before coming to the Laplace transformation, so let us try to understand how the things will transform. So let us take an improper integral. Integral of the form Laplace integral of the form minus infinity to infinity k of s comma t f of t dt. So this is an improper integral because the limits are what? Undefined. Now this particular term is very special. This is called kernel of the transformation, or kernel of the transform. So depending on this particular transformation, this particular kernel, this particular improper integral will change to different form. So when this transformation or this particular improper integral will become Laplace transformation, for that we have to take like this. Let us define this particular kernel like this. It will be e to the power suppose minus st for t greater than equal to 0, and it will be 0 if t is what? Less than 0. So for all negative t, kernel will become 0, but for all positive t, it will become e to the power minus st. So this is the standard one for Laplace transformation. So let us take this particular integral as equation number 1. Now, how equation 1 we can define? It is actually minus infinity to infinity k of s comma t f of t dt. So this is equals to, we can break it like this: k of s comma t f of t dt, and then plus 0 to infinity k s comma t f of t dt. Okay, we split it into two different integral. But see here, t less than 0. T less than 0 means what? From minus infinity to 0. For minus infinity to 0, what is the kernel? Kernel is here 0. So this particular integral, this particular integral will become 0. So we'll only have 0 to infinity k of s comma t f of t dt. Now what is k of s comma t? So we suppose that for t greater than 0 means for 0 to infinity, it will be always how much? E to the power minus st. So now it will become 0 to infinity e to the power minus st f of t dt. Okay. So this particular integral is called what? Laplace transformation. Laplace transformation. And how we denote this? We denote it like this: Laplace of f of t. Or we can denote it like this also: small f of s. So this is the integral form of what? Laplace transformation. So in our coming lectures, we'll learn some properties of theorems on Laplace transformation, then some application, and then we'll go to inverse Laplace transformation. Okay, so I hope together we'll learn in a very proper way, and it's very easy. Laplace transformation is very easy. So thank you for watching the video till now. Kindly subscribe and share with